Earth is 4.5 billion years old. Modern humans, we've only been around for about 300,000 years. So what was happening on our planet before we showed up? Was it just empty? Or could there have been other advanced civilizations that came before us? Civilizations so ancient that all traces of them have been wiped away. This is the heart of the Silurian hypothesis, a fascinating scientific thought experiment proposed in 2018 by astrophysicist Adam Frank and climate scientist Gavin Schmidt. They asked a simple but mind-blowing question. If an industrial civilization existed on Earth millions of years ago, would we even be able to tell? The hypothesis is named after the Silurian period, a time over 400 million years ago when life was thriving in Earth's oceans. But the name is also a nod to Doctor Who, where the Silurians are an ancient reptilian species. It's a clever way to frame the idea, but the science behind it is serious. So, if there were advanced civilizations before us, where are all the ruins, the tools, the skyscrapers? Well, that's the thing. Earth is a master at recycling itself. Our planet is constantly changing. Mountains rise and fall, oceans become deserts, and entire continents shift over millions of years. Processes like plate tectonics, erosion, and volcanic activity are like nature's cleanup crew. Think about it. If humanity disappeared today, how long would it take for all traces of our civilization to vanish? Scientists estimate that within a few million years, even our toughest structures, like skyscrapers and nuclear waste sites, would be ground into dust and scattered across the planet. So, if our civilization can disappear so completely, what chance do we have of finding evidence of one that existed hundreds of millions of years ago? This is where Frank and Schmidt's idea gets really interesting. Instead of looking for physical evidence, they proposed searching for chemical fingerprints in Earth's geological record. For example, carbon isotopes. Burning fossil fuels changes the ratio of carbon-12 to carbon-13. If an ancient civilization used industrial processes, we might find these anomalies in ancient rock layers. Nitrogen levels. Synthetic fertilizers could leave behind unusual amounts of nitrogen-15. Radioactive isotopes. If they used nuclear technology, we might find traces of plutonium-24 or iodine-129. Elements that don't occur naturally in large amounts. But here's the catch. Natural processes can also produce similar chemical signatures. For example, massive volcanic eruptions can release huge amounts of carbon dioxide, altering isotope ratios. So, how do we tell the difference? One of the key pieces of evidence Frank and Schmidt looked at was the Paleocene-Eocene thermal maximum, PETM, a period about 56 million years ago when Earth's temperature spiked by 5 to 8 degrees. This event released a massive amount of carbon into the atmosphere, similar to what humans are doing today. Could this have been caused by an ancient industrial civilization? It's a fascinating idea, but most scientists aren't convinced. The PETM was likely caused by natural processes, like volcanic activity or the release of methane from ocean floors. Plus, the rate of carbon release during the PETM was much slower than what we see today. So, if the PETM wasn't caused by ancient factories, what other clues could point to a lost civilization? Some researchers have suggested that dinosaurs might have been more advanced than we think. Take the Troodon, for example. This small bird-like dinosaur had a large brain relative to its body size, binocular vision, and grasping hands, traits that suggest it could have been capable of complex behavior. Paleontologist Dale Russell even speculated that if dinosaurs hadn't gone extinct, Troodons might have evolved into intelligent, human-like creatures he called dinosauroids. But let's be real, even the smartest dinosaurs were probably nowhere near building cities or launching rockets. So, what about something even stranger, like a civilization based on fungi? In 2000, a Japanese biologist named Toshituki Nakagaki conducted an experiment that blew everyone's minds. He placed a slime mold in a maze with a sugar cube at the end. Within hours, the mold figured out the shortest path to the sugar without a brain. This raises a wild question. Could fungi or other simple organisms have formed some kind of ancient intelligent network? If so, their civilization would leave behind no physical traces, just subtle chemical clues. Of course, not everyone is on board with the Silurian hypothesis. Critics point out that there's no direct evidence, no tools, no buildings, no artifacts. All the proposed chemical traces could be explained by natural processes. Evolution makes it unlikely that any species before humans could have developed advanced technology. So, was there an ancient civilization before us? The answer is, we don't know. But the Silurian hypothesis isn't really about proving the existence of lizard people or dinosaur engineers. It's about challenging our assumptions and asking, what don't we know about Earth's history? And who knows, maybe one day we'll discover a clue that changes everything.
Seen a good horror movie lately? If you're a fan of those, then you can appreciate a good plot. But what if I told you that Mother Nature is the best scriptwriter ever? Ancient disasters were scarier than any horror movie today. From tsunamis to volcanic eruptions, you'll be shocked by the scale of these events. One natural disaster you definitely don't want to experience is a tsunami. Those gigantic walls of water sweep across the coast and take out everything in their way. And it's nothing new for our planet. Scientists were able to piece together a timeline based on evidence that major tsunamis left. In northern Chile, a large boulder sits high above the Pacific Ocean. Behind it, a desert as far as the eye can see. This 44-ton stone obviously doesn't belong here. It's the result of an ancient tsunami. Waves as high as a 6-story building carried boulders like pebbles. Researchers estimate this happened in 1420. But how can they possibly know this? In the 15th century, there were no written records in the region. Time for some detective work. Archaeologists discovered that around the same time, there was a tsunami in Japan, on the other side of the Pacific Ocean. The ground shook off the coast of Chile. That's how the tsunami was created. Then the wave traveled nearly 2/5 of the Earth's circumference. That's one tireless tsunami. But this wasn't a one-time event. Evidence suggests that a similar event happened 3,800 years ago. Ancient people abandoned their coastal villages around this time. They were moving inland. How did they know it was time to go? There's evidence of erosion due to strong currents, telltale signs of an ancient tsunami. As you know from school textbooks, oxygen is 21% of the air we breathe. But it wasn't always a part of Earth's atmosphere. Oxygen was missing during the first half of our planet's lifespan. Carbon dioxide and methane were the name of the game back then. CO2 is what makes our drinks fizz. But isn't the other gas dangerous? Yes, because you can't smell methane. And that's the reason there was no life on Earth billions of years ago. So how did we get from methane to oxygen? In come the cyanobacteria. This group of microbes started to evolve some 2.7 billion years ago. These tiny microbes mastered photosynthesis, converting sunlight into energy. And the byproduct of this process was, you've guessed it, oxygen. Soon it started escaping from water into the atmosphere. There, it reacted with methane, and over time, O2 replaced it completely. Scientists named this process the Great Oxidation Event. But how could it be bad? After all, we're alive thanks to it. All that oxygen acted as a poison for anaerobic organisms. And no, these are not life forms that didn't do aerobics or Pilates. The term simply means that these microorganisms didn't need oxygen to grow. Too much oxygen, and they would be goners. And that's precisely what happened. Scientists spoke of an oxygen overshoot that changed Earth's atmosphere for good. The disappearance of most anaerobic organisms was an early example of an extinction event. They didn't like the atmosphere at the time and decided to step down. But look on the bright side. They made room for oxygen-loving humans to enter the picture. Let's go to Turkey. No, not the seaside resorts that tourists visit in the summer, but the region of Anatolia in the southeast of the country. Göbekli Tepe is the world's oldest known temple site. It dates back to the Neolithic period. Scientists found a stone pillar here that tells a tale of an ancient disaster. They presume that the pillar is commemorative. Today, humans still build similar structures to mark an important event or a person. Just one example is the Washington Memorial. It was built in honor of the first American president, George Washington. But the pillar in Turkey doesn't commemorate a happy event. Scientists believe it shows a devastating occurrence, a comet crashing into the Earth. The event must have been destructive. There are also other signs on the monument. These symbols align with the setup of the night sky stars for the year 10,950 BCE. The date astounded the researchers. It matched their earlier research of an ice core sample in Greenland. This showed that a comet fragment hit our planet around the same time. The archaeological site could have easily been an ancient observatory. And whoever worked at it observed a cataclysmic event. The impact must have been so powerful that it changed the Earth's rotational axis. That's the imaginary pole going through our planet from top to bottom. That ancient comet must have packed a punch to knock the blue planet off balance. Have you heard of the city of Tal El Hammam in the valley of the Jordan River? The reason why your answer is probably no is that the city doesn't exist today. It completely disappeared around the year 1650 BCE. It was one of the three major cities in this part of the Middle East. Together, these three cities had a population bigger than Palm Springs today. At the time, Tal El Hammam was a metropolis. It even had high-rises, 5-story buildings constructed using mud bricks. But archaeologists found strange markings on them. The bricks melted as they were exposed to high temperatures. Yes, sound the fire alarm. Some sort of disaster had caused a major fire. Archaeological finds pointed to a suspect for such damage: a rock from space. So, where was the crater? This comet, or an asteroid, never made it to the ground. It was traveling at high speed, so it disintegrated before hitting the ground. Such an event is called an airburst. The largest witnessed meteor airburst happened over Tunguska in the north of Asia in 1908. Scientists estimated that the airburst in Tal El Hammam happened 2.5 miles above the city. This event released a lot of energy. Air temperature quickly rose to 3,600 degrees Fahrenheit. That's hot enough to set clothes and wood on fire in an instant. Mud bricks and tools made from metal start to melt when exposed to such heat. This would explain the evidence scientists unearthed. But there was one more find: salt. The event was so powerful that it distributed salt over the region around the Dead Sea. Any farmer will tell you that salty soil and crops don't go well together. People started moving away from the area because they couldn't grow food. Imagine an island with whitewashed villages surrounded by a sapphire blue sea. Such a place exists in reality. It's the island of Santorini. But the history of this place hides a tale of destruction. The island is of volcanic origin. This means that a violent eruption created it some 3,000 years ago. Now there are two islands. The bigger one is shaped like a horseshoe. When you look at them from above, the two islands look like they form a circle. That's because they were once a single island. It had a large mountain and was round in shape. But then it all changed almost overnight. One of the largest volcanic eruptions in human history tore Santorini apart. The earth trembled, tsunamis formed, and clouds of ash filled the sky. A daunting image. People felt the eruption hundreds of miles away. When it was all over, seawater rushed into the caldera of the former volcano. That's why the water in the lagoon has such a beautiful color. Scientists know so much about Santorini's past because of an unlikely assistant, A tree. The juniper tree, to be exact. People use its aromatic wood for everything from furniture to making pencils. On the Greek island, its rings revealed the tale of the ancient eruption. As a tree grows, it doesn't only go up, it expands sideways as well. Each new layer of bark adds a ring to the trunk. It takes a year for one ring to form. And on Santorini, one ring was unnaturally pale. The scientists did the math and voila, they dated the eruption to 1560 BCE.
Phantasmagory is said to be the first animated film ever. It was made in 1908, and it's one of the earliest examples of hand-drawn animation. But did you know that ancient people entertained children with cartoons about 2.6 million years ago? A new study reveals that ancient people were the ones who first made pictures look animated. How? They carved pictures of animals on stones and placed them around fires. When the light starts bouncing around, those ancient animals just can't help but shake it and shimmy. The prehistoric carvings come to life in the flickering firelight, with those animals jumping in and out of focus like they're ready to party. Imagine how fun it would have been for prehistoric families to sit around a fire and create these animated carvings. It turns out that even some of the ancient wall paintings and carvings found in caves were inspired by their appearance in the moving light and shadows of flames. So, basically, these old-timey carvings were made to come to life when firelight hit them. And now researchers made a movie showing that cool effect on a 3D model of some horse engravings. The study says our brains are wired to see moving things in changing light, which is why these carvings probably mattered to our ancestors. In other words, cave people were like, hey, let's carve some cool stuff on this rock, and when we light a fire, it'll look like it's moving. And now these scientists were like, that's awesome! Let's make a movie to show this, everyone! Andy Needham and his teammates used modern scanning and virtual reality tech to study 50 flat carved rocks called plaquettes made of limestone. These rocks were found in southern France back in the 1800s and now sit in a museum in London. They are covered in 77 realistic carvings of all sorts of animals, like horses, reindeer, and chamois. Apparently, Homo sapiens, with a lot of time on their hands, made these engravings a whopping 12,000 to 16,000 years ago. Needham realized that many of these carved rocks were harmed by fire, some covered in white ash, others dried or fractured because of heat. Upon closer examination, he discovered pink bands of discoloration resulting from iron deposits in the stone. What's more interesting is that the animal engravings were often superimposed on top of each other, sometimes even melded together, or fitted around each other like some kind of prehistoric animal jigsaw puzzle. Rather than tossing out the old and starting anew, the ancient artists took animal body parts to create new hybrids. For instance, one of the rocks depicts both a horse and a wild cattle-like creature known as a bovid. In this masterpiece of prehistoric art, the horse's abdomen and neck become the back and neck of the bovid, while the horse's head forms the bovid's ear. What a creative way of recycling. Researchers believe that the prehistoric rocks from Montestric were used as primetime entertainment for our ancestors. More than one person carved the animals. People from different levels of skills showed their artistic glory, and it was a group effort. The fact that these rocks were found together also suggests that this was a community activity. So it's like families were all gathered around the TV, carving rocks and cheering on their favorite carved animals. Who needs Netflix when you have Paleolithic TV? The engravings on these rocks and the signs they were exposed to heat suggest they were created to look like they were moving. Sometimes you see different animals in different poses, so one would come to life, and then another, and then a different one. It's like a Stone Age version of Disney. Similar techniques might have influenced some of the ancient cave paintings, such as those at the breathtaking Chauvet Cave in southeastern France. The animal portraits there are also overlaid on each other, and some look like they were heated by fires underneath them, which means that our prehistoric ancestors might have been the first animators in the world. Alright, since we talked about young people's favorite pastime activity, shall we take a trip back in time to discover the world's oldest toys? One of the most ancient toys discovered was a simple ball made from clay and found in the ruins of ancient Mesopotamia. It might seem like a simple toy, but our ancestors were playing with them as far back as 3000 BC. But back then, they didn't have fancy video games or elaborate board games, so a ball was the pinnacle of entertainment. But the Mesopotamians weren't the only ones having fun. In ancient Greece, children played with dolls made of clay. In Egypt, kids had toys shaped like animals, but they also had dolls made from materials like clay, papyrus, and ivory. But the most impressive thing about these dolls? They had movable limbs. That's right, our ancient ancestors were playing with articulated dolls before it was cool. But it's not all fun and games. Toys also had a practical purpose back in the day. In fact, many of the toys discovered by archaeologists were actually used to teach children important skills. For example, Egyptian children played with dolls that were shaped like doctors, which helped them learn about medicine and healthcare. And let's not forget about the toys that were used to train future warriors. In ancient China, kids played with toy horses and chariots, which helped them prepare for a life of battle. Talk about getting a head start on your career. Moving on to primitive board games, which have been around for over 5,000 years. The oldest board game is called Senet, and was discovered in ancient Egyptian tombs. It's a bit like a cross between chess and backgammon, and it was so popular that it was played for over 2,000 years. Now that's a game with staying power. But let's not forget about toys for the little ones. Archaeologists have found ancient rattles and whistles that were used to entertain even younger members of their families. And if you thought your kid's toy collection was impressive, just wait until you hear about the ancient Egyptian princess who had over 100 wooden toys in her chamber. But perhaps the most surprising toy of all was the yo-yo. That's right. The yo-yo has been around for over 2,000 years. It was first invented in ancient Greece and was often used in battle, believe it or not. But eventually people realized that it was much more fun to just play with it and do tricks. Marbles are also around as a toy that has been entertaining kids, and some adults, for thousands of years. Archaeologists have found evidence of marble dating back to around 5,000 years ago in the Indus Valley civilization. Back in those days, marbles were made from all sorts of things. Want to take a wild guess? Okay, I'll tell you. Fruit pits and small pieces of smoothed stone. That's right, those ancient kids were getting creative with their playthings. Some artisans even went the extra mile and crafted marbles from clay. Let's head back to ancient Egyptians and their adorable miniature boats made from ivory, wood, and clay. These miniatures may be acknowledged as toys, but they were also meant to represent crossing over to the other side. Viking kids had similar types of items too. A wooden toy boat over 1,000 years old was found on a farmstead near the coast of Norway. This toy looked like a real boat, and it would have been the ultimate cool thing, just like how kids today go nuts over race cars and drones. You can imagine little ones back then showing off their toy boats to their friends. Many of these toys are still pretty fun to play with today. There are many others left aside, like toy soldiers and spinning tops. Do you want to know more about ancient toys or gadgets from the early days of cinema?
In 1850, French scientist Auguste Mariette went to Egypt looking for manuscripts, but accidentally found a head of a sphinx sticking out of the dunes. He cleared the sand and figured out the sphinx was guiding the entrance to some underground construction. Several months later, he finally entered the Serapeum of Saqqara. Inside, he found an enormous granite sarcophagi with remnants of 64 bulls. Scientists are still amazed by the tech that the ancient Egyptians used to transport those enormous boxes. The Serapeum was built around the year 3000 before the Common Era. It was an underground tomb built to honor the sacred Apis bulls of ancient Egypt. It had a long hallway, almost 500 feet long, with giant stone rooms on both sides. Some of the sarcophagi weighed as much as 50 average cars, and all of them were made with super precision, with exact 90-degree angles. These sarcophagi were beautifully decorated with hieroglyphs and carvings that told stories about the lives and importance of the Apis bulls. Now, there are 24 sarcophagi left. In ancient Egypt, Apis bulls were very special animals connected to the deity Ptah. They thought the bulls carried Ptah's spirit and wisdom, helped the pharaoh, and protected the Egyptians. Priests looked for special markings on young bulls to find Apis bulls. It could be a white triangle on its forehead, which symbolized divine light, a shape on its back like a vulture's wing, and a scarab shape under its tongue, which stood for rebirth. If a bull had these signs, They believed it was chosen by Ptah and treated it like royalty. The chosen bulls lived in a special temple in Memphis, the city where they worshipped Ptah. They received the best care and offerings from visitors who wanted their blessings. When an Apis bull passed away, it was treated with great honor and mummified. When Mariette entered the Serapeum, he noticed traces of rollers on the gallery's floor and found 2 wooden horizontal winches. Each had 8 levers. Later, other explorers saw double rails. The burial chambers were lower than the hallway floor. To get the boxes into place, workers filled the chambers with sand so the sarcophagi could be rolled in straight. Then they slowly removed the sand to gently lower the boxes into perfectly cut spaces in the bedrock. A carved stone sign found in the Serapeum said it took 28 days to move just one sarcophagus and its lid into its spot during the time of Ptolemy II. The extreme precision of the sarcophagi with 90-degree angles also has an explanation. Ancient Egyptians wrote texts, or rather, papyrus, on geometry a long time ago. It shows that they knew the approximate number pi and could calculate the volume of a pyramid with its top cut off. If they could figure out complicated math like that back then, it makes sense that they could also carve perfectly flat surfaces 500 years later. All this sounds pretty legit, but some people think certain things don't add up here. The size of boxes is way larger than the size of bulls, yet they buried pharaohs in tiny coffins that barely fit their bodies. The sarcophagi are made out of granite with crazy precision, and they could have just used limestone, which would have made things way easier. The transportation of the boxes seems pretty simple, but only in theory. If one person could pull about 440 pounds, then at least 250 people would be needed to pull just one box. The tunnels in the Serapeum are really narrow, only about 2 feet wider than the boxes themselves. There's no way hundreds of people could have squeezed into those tight spaces to pull the boxes. And even if they did, how would they turn the box in the cramped corridor, lower it into its niche, and place it perfectly in the middle? Somehow, they did this 24 times, and every box is centered perfectly. Plus, the chambers were dusty, and there were no signs of soot from lamps. This means they must have worked in almost complete darkness. The real use of the boxes could also be different. A long time ago, even before the Egyptian pharaohs ruled, the local people already knew how to use fermentation. It happens when tiny organisms called yeast eat certain ingredients like starch and turn them into gas and ethanol. So someone in ancient Egypt probably put food like barley, bread, and even meat inside a giant stone box, then closed it tight with a heavy lid. These stone boxes, carved from granite, were so precisely made that they were almost completely sealed, so nothing could escape from it. As the yeast inside the box started working, it created more and more CO2 gas. It built up pressure inside the box. The granite boxes were incredibly strong. They could handle more pressure than a car tire can hold. When granite was squeezed under such pressure, its crystals produced a tiny electric charge. This effect was possible because granite contains quartz, a material that reacts to pressure this way. The process also needed meat or animal parts, possibly to help the yeast grow better. Meat contains something called oleic acid, which yeast needs to keep growing and to survive the bad effects of the ethanol it produces. As the pressure inside the box kept growing, the combination of gases and electricity made these boxes not just ancient fridges, but powerful energy systems. Over time, the pressure inside got so strong that it could push the lid open and the gas would escape with a pop. But when people rediscovered the Serapeum in 1850, they found old drawings that showed piles of stones stacked on top of some of the box lids. So, someone long ago probably tried to make the lids even heavier by adding extra weight to make it harder for the gas pressure to push them open. This extra weight also meant the quartz crystals in the granite could keep creating more electricity under all that pressure. If someone opened one of these stone boxes thousands of years later, they would only find bones from bulls that were placed in the box. And that's exactly what Mariette discovered in the 1850s. They opened the Serapeum for visitors soon after the first excavations in the second half of the 19th century. Prince of Wales even had a luncheon with his guests in one of the sarcophagi. Sands and earthquakes made the site inaccessible for a while, but now you can visit it again and try to solve the mystery yourself. With new tech, we could have answers to many other historical mysteries soon. A team of scientists at Chicago's Field Museum of Natural History recently used a special CT scanner to learn more about ancient Egyptian mummies without unwrapping them. They gently rolled 26 mummies on custom carts out to the parking lot, where the scanner was waiting. It took thousands of detailed X-ray pictures of each mummy and their coffins. When all the pictures were put together, they created 3D images that showed what was inside, the skeletons, and some artifacts. The scientists hope these images will help them understand ancient Egyptian burial practices from over 3,000 years ago. Even though the scanning process only took 4 days, it might take 3 years to study all the data. But scientists were able to learn some personal details about the mummies. One of the most popular mummified individuals at the museum, Lady Chineta, was a woman who lived in ancient Egypt about 3,000 years ago. It looks like she passed away in her late 30s or early 40s. To make sure her body looked complete for the afterlife, embalmers put stuffing in her neck to keep it from collapsing. They also placed artificial eyes in her sockets, so she would have eyes in the next world. She was wrapped in fancy linen and placed in a beautifully decorated coffin. The scans revealed that it had been carefully crafted with a slit at the back, which embalmers used to fit the body. There were also some artistic details on the surface, like markings for her knees. It looks like her burial was on the scale of a high-end luxury car.
It's 1898, and you're taking part in excavations in Saqqara. This place, not far away from Cairo, is full of ancient tombs and pyramids. You're in your Indiana Jones mood and hope to find something really phenomenal to become famous. Gold, manuscripts, treasure maps, mummies of famous pharaohs. Wait, a wooden bird? You're really disappointed as it looks like a regular toy. An old one, but still. Little do you know that years later, someone would propose that your bird was actually an ancient monoplane. So the artifact, nicknamed the Saqqara bird, is made of a sycamore tree. The birdie has a wingspan of just 7 inches and weighs around 40 grams. A perfect original souvenir from Egypt, I would say. It's over 2,000 years old and looks pretty plain, without any carvings of feathers or other intricate ornaments. It has a beak and eyes though, which makes our find look like a hawk, the emblem of the deity Horus. Its tail is rather unusual as it's squared, looks weirdly upright, and it seems like the sunken part of it was the place for a now missing piece. Humans love solving a good mystery, so there have been several attempts to explain the use of the birdie. First, quite simply, is that it was a ceremonial object. The second idea is that it was a toy for a child from some well-off family. It could have been some sort of boomerang, which was a popular concept in ancient Egypt. Then there was a theory that the bird had been used as a weather vane. But this one has been debunked as the figure doesn't have any holes or markings, except for the one made at the museum in Cairo to fix the exhibit on a stick. So there was no way to hang it in the past. Almost a century after the bird was found, Egyptologist Dr. Khalil Masiha proposed a new theory that it could have been a model of a monoplane. He believed the bird was missing a horizontal tailplane. Otherwise, it had its wings set at a right angle, similar to that of modern planes. It could have worked to generate the aerodynamic lift necessary for flights. Dr. Masiha also claimed that it was common at that time to place miniature models of technological inventions in tombs. So, did the ancient Egyptians really invent the plane in 200 BCE? That would make the Wright brothers, who are considered the inventors of aviation, really upset. They made one of their first flights only in 1903. There's just one way to know for sure, and that is to test the model. But you know, the ancient museum in Cairo would unlikely let one of their cherished exhibits fly around like a toy. That's why glider designer Martin Gregory built a similar model, this time of balsa wood, and concluded that even with the missing tailplane, the plane wasn't much of a flyer. Case solved? Not really. This didn't sound convincing enough to the History Channel, so they invited an aerodynamics expert to build another replica of the bird. He tested it in weather conditions similar to those in Egypt and was impressed with the little plane's abilities. So, if they did invent the prototype of a plane back in the times of pharaohs, it would be a good example of an oopart. That's an out-of-place artifact, an object that's way ahead of its time in terms of technology or history. And the Saqqara bird isn't the only example of such a revolutionary concept. In 1901, a group of divers retrieved the Antikythera mechanism from an underwater shipwreck near the Greek island of Antikythera. It's been dubbed the world's first analog computer, and it's currently dated around 100 BCE. The bronze mechanism could tell the position of the sun, moon, planets, and stars, as well as the lunar phase, the dates of upcoming solar eclipses, and even the speed at which the moon moves through the sky. No one's sure who used it and how or where it was made. But it's obvious that it's extremely precise and way too advanced for its time. The first flushing toilets in the world were invented in the middle of the 20th century. Just kidding. The ancient Minoans on the Mediterranean island of Crete and the Indus Valley civilization both came up with this brilliant invention at the same time, around 4,000 years ago. The plumbing and sanitation were so well done that no one managed to design anything better until 2,000 years later. One ancient Minoan lavatory was discovered at the Palace of Knossos. It looks like it had a wooden seat set over a tunnel that directed water from a rooftop reservoir to an underground sewer. Other varieties got water from jugs. Only the super rich people could afford all this glory. So if you wanted to shop for real estate back then, the flushing toilet would be a telltale sign you were in the rich neighborhood. Automated doors became a cool, seemingly new invention back in 1931. But the technology behind them is actually much older. Think the 1st century CE old. Mathematician and engineer Heron of Alexandria came up with a hydraulic system to open and close temple doors. To bring it into action, you need to light a fire to produce heat. There was a brass pot under the fire, half filled with water. The inventor connected the brass pot to containers that acted as weights. When the fire was burning, the water moved into the containers. They went down and pulled the ropes. It was nothing like a supermarket door that opens in front of you before you even have time to think. Heron's door took hours to open, and there was no way to stop the process. That's why they only opened the doors once a day before people entered the temple, to add some mysticism at the temple during ceremonies. Spooky. Looks like the first ever battery was invented in Baghdad around 2,000 years ago. A German archaeologist found this oval-shaped clay jar in 1938. Scientists are still not sure what purpose it served and who exactly invented it. There is a theory that it was used for electroplating objects with precious metals. When they filled it with a weak acid like vinegar, the battery produced around 1 volt of electricity. Another theory says it was a vessel for sacred scrolls. Would you like to buy contact lenses designed by Leonardo da Vinci himself? In 1508, he invented a glass lens with a funnel on one side. You were supposed to wear it with water inside to improve your vision. Sounds a bit uncomfortable, doesn't it? So, around a century later, French scientist René Descartes decided to improve the idea and make the cornea contact the future lenses. Contacts because they contact your eyes, get it? The glass tube with liquid did help improve vision, but blinking was sadly impossible. 2.5 centuries later, New technologies in the glass industry let scientists design contacts that would fit in the eye and even let the wearer blink. Thanks, guys! Still, those lenses were made of heavy blown glass and didn't let the eye breathe. About 50 years later, contacts became plastic, lightweight, unbreakable, and scratch-resistant, but still covering the entire eye. And then, in 1948, an English optical technician accidentally sanded down a plastic lens and figured out they'd still be in place even if they covered only the cornea. Imagine you're living in 19th century London and need to send a message to New York. It would have taken about 10 days to get there by ship. So when delivery time went from days to hours in 1858, it was a true sensation. The first message was sent by Queen Victoria herself. It was all made possible thanks to the transatlantic telegraph cable, running under the ocean. Sadly, the new cool invention only lasted a few weeks. It took years to bring it back to life. It was the spring of 1900 when a group of Greek sponge divers got blown off course by a storm and came across a wreck of an ancient Roman ship. The vessel, which had sunk more than 2,000 years before, was literally loaded with treasures. A year later, a spectacular haul of antiquities was brought up to the surface, and among those precious items, there was something amazing. Divers found a startlingly complex cosmological calculator. It was one of the world's first analog computers, and it was made by the ancient Greeks between the 3rd and the 1st century BCE. It could track the phases of the moon and the position of the planets, but we can't give all the credit to the Greeks. Most scientists believe that their knowledge was based on the learning of a much earlier civilization. The ancient Babylonians were considered the first astronomers, and no wonder, they were enthusiastic stargazers. For example, around 6,000 years ago, they built watchtowers to scan the sky. And after mapping the stars and visible planets, they recorded their observations on clay tablets. Now, let me tell you about the most paradoxical thing. The observations made by the ancient Babylonians were extremely precise. They were the first known people to predict eclipses. They successfully calculated the length of a year. But their understanding of the cosmos? Oh boy, it was so different from ours. See for yourself. They imagined their world as an oyster surrounded by water. Their sky was a solid dome. Moisture sometimes seeped through this dome as rain. The waters from below sometimes broke through this dome in the form of natural springs. And every day, the sun, the moon, and the stars took part in a slow dance across the ceiling. They entered from the east and exited in the west. Now let's move on to another great nation, the ancient Egyptians. Their universe was rectangular, kinda box-like. At first, they believed the sky was a cow, with each of its feet planted at each corner of the rectangular earth. Later, they changed their mind. They started to compare the sky to a vaulted metal lid. The deities of the sun and moon sailed along the river, flowing upon an elevated gallery running around the inner walls of the box. Early Greek cosmology was no less exciting. Their world resembled a floating disk that was surrounded by Oceanus. That was a majestical mythical river encircling the world. But this theory was soon debunked. With time, the ancient Greeks started making tremendous advances in figuring out how the universe actually worked. Even better, they became the driving force behind the development of Western astronomy and science. If we speak about the solar system, in the past, there were two theories about what it looked like. The first one was called heliocentric. That's because the sun was considered to be the center of the known universe. Earth was believed to revolve around the sun once a year and rotate around its axis once a day. At least, this theory managed to correctly map all the planets known at that time in order of their distance from the sun. The other theory was known as the Earth-centered model of the universe. According to it, our planet was the center of the universe, and all other space bodies, including the sun, rotated around Earth. This model was around for about 1,400 years. It was toppled only in the 16th century, You might have heard that in the past, people believed that our planet was flat. Interestingly, this myth had already been debunked by the 5th century BCE. It was widely accepted that our planet was a sphere. Ancient astronomers watched lunar eclipses and observed the shadow our planet cast on the moon. It was clearly round, which made them conclude that Earth was a sphere. And still, despite some correct theories, the ideas of ancient civilizations about the world often seem somewhat funny and naive to us. On the other hand, guys, I guess the day will come when our descendants will start discussing our theories about space, and I bet they'll find them both ridiculous and amusing too.
There are several places on Earth, awesome and mysterious, that evoke so many questions that some people believe they were built by or with the help of extraterrestrial intelligence. Let's explore those mystical destinations. In the hills above Cusco, Peru, you'll find an ancient Inca fortress called Sacsayhuaman. Some of the massive stones of its walls weigh as much as 360 tons. They're cut and fitted together surprisingly precisely, and no mortar is used. The stones used for this construction were transported over 20 miles from quarries. But how did the Inca do it? Did they ask for extraterrestrial help? Perhaps. But archaeologists disagree. They have found evidence that the Inca used advanced engineering techniques involving ropes and levers to move and fit the stones. Okay, let's move on to the Nazca lines. You can see them in the deserts of southern Peru. In this area, more than 800 lines and 300 shapes stretch across the deserted landscape. Those are called geoglyphs and are best viewed from the sky. That's how theories about alien involvement popped up. The lines were made by removing the top layer of reddish rocks to reveal the lighter ground beneath. And this is a pretty simple technique. You don't even need to use modern tools. The purpose of the Nazca lines is still a mystery, but most experts believe that they had some ceremonial significance. Now, the stone circle of Stonehenge must have something to do with extraterrestrial visitors, right? Those stones, some weighing as much as 50 tons, were brought from quarries hundreds of miles away. No wonder many people offered theories about alien intervention. Well, sorry to disappoint you, but archaeologists have proven that the monument could have actually been built with the help of technologies available around 5,000 years ago, such as wooden sleds and rollers. The exact purpose of Stonehenge is still under debate. Its builders could have used the stone circle to track the sun or to perform astronomy-related rituals. The next breath-stopping place on our list is the Egyptian pyramids, namely the pyramids of Giza just outside Cairo. They were built over 4,500 years ago. The largest of them, the Great Pyramid, is made of millions of 2-ton stones which are arranged with super precision. The pyramids also align with the stars of Orion's belt, and this makes some people believe that aliens might have helped to build these awe-inspiring constructions. Experts disagree. They say that although the exact methods the Egyptian builders used are still unclear, the pyramids are undoubtedly a human achievement. Ramps, levers, and a large workforce were likely used to move the stones into place. Then, how about Teotihuacan, located near modern-day Mexico City? Once, it was a thriving metropolis. The city was built more than 2,000 years ago, and its size and advanced architecture make people wonder if aliens played a key role in its construction. In reality, the city was created by several cultures, including the Maya and Zapotec. It was a center for trade, agriculture, and other activities, but it does have some connection to space. Its layout, with the pyramids aligned to celestial events, shows a deep understanding of astronomy. And still, it was the work of human hands. Now, let's travel to one of the most mysterious islands in the world, Easter Island. Nearly 900 stone figures known as moai stand there, some towering over 30 feet tall. These statues were carved from volcanic rock more than 1,000 years ago and moved across the island to their final resting places. This impressive feat, as well as the slightly creepy appearance of the figures, makes you think about some alien intervention, doesn't it? Well, another disappointment. It's believed that the Rapa Nui people used wooden sleds or rolling logs to transport the statues, and there's no evidence that extraterrestrials were involved. The last destination isn't even on Earth. In 1976, NASA's Viking 1 orbiter captured an image of what seemed to be a face on Mars. It sparked numerous theories about alien activity. The face seems to be staring up from the Martian surface, like evidence of the activity of an ancient alien civilization. But more detailed images from 2001, taken by the Mars Global Surveyor, revealed that the so-called face was just a natural mesa, an isolated flat-topped hill with steep sides.
It seems that humanity has gone a long way since the first people appeared on Earth. We've invented so much cool stuff and developed new technologies. We've risen above other species after having built an advanced civilization. We've come from living in caves and cooking our food on fire to walking on the moon and creating 3D breakfasts. Does it mean we can be considered a Type 5 civilization? Oh, I see you're confused. Let me tell you about these civilization types and what they mean. The Type 1 title is given to species that have managed to harness all the available energy of their home planet. That's why this civilization is called a planetary civilization. They gather and store this energy to satisfy the demands of a growing population. We would need to boost our current energy production more than 100,000 times to get to this stage. And then we would be able to get control over all natural forces on the planet, like volcanoes, storms, or earthquakes. It's hard to believe, but it's actually a very basic level. You'll see it later. As for now, let's move to a Type 2 civilization. It can use and store energy at the scale of a star system. That's why this type is often called a stellar civilization. Experts have suggested several potential ways to do it. The most popular one is called the Dyson Sphere. This hypothetical device could encompass every single inch of a star, gathering its energy and transferring it to the planet. What would so much energy mean for the Type 2? First of all, nothing we know about could wipe out such a developed civilization. Let's say a moon-sized object entered our solar system and was heading towards Earth. No need to panic. We would be able to vaporize it as soon as we noticed it. Or maybe we'd just move our planet out of harm's way. Now, a Type 3 civilization can control energy at the immense scale of the entire host galaxy. That's the reason it's called a galactic civilization. The inhabitants of such a civilization would probably be totally different from the human race. They could be cyborgs, both biological and robotic beings. Maybe there would be colonies of robots capable of self-replication. They would spread across the galaxy, colonizing star systems. And still, these species would be restrained by the laws of physics, unless they figured out how to travel at the speed of light. At first, the scale describing civilization types didn't go beyond Type 3, but later, it was extended, and that's how Types 4 and 5 appeared. A Type 4 civilization knows how to harness energy at the scale of the universe it lives in. This could probably allow its inhabitants to live inside supermassive black holes. In any case, they would need to tap into energy sources we can't even imagine at the moment, using currently unknown laws of physics. And finally, an incredibly advanced Type 5 civilization might be living somewhere out there. If we reached this level, we would be able to manipulate energy both within our universe and other universes. Of course, at the moment, we're a very long way from achieving a Type 5 civilization, but it's not impossible. Assuming our world remains intact, we might continue advancing with every next generation. Then, a day may come when we'd be able to travel anywhere we want in the multiverse. Maybe we'd even use wormholes. Theoretical bridges using space-time that creates shortcuts, reducing travel distance and time. We'd be able to tap into mysterious dark matter to produce energy. And we would find the answers to tons of mysteries about us and the universe. But guess what? At the moment, we're not even a Type 1 civilization. Yep, we're not even on the scale yet. Duh! First of all, we're facing some physical limitations of each type of energy source. Plus, we'd need to balance them not to trigger even more climate changes and not make pollution levels rise. Scientists researching this question have concluded that humanity could potentially reach the level of Type 1. But it wouldn't happen until at least 2371.
So how alone are we in our galaxy? Crickets. Yep, we're mostly alone out here. But are there other civilizations lurking somewhere out there in the depths of the Milky Way? Could they possibly have evil intentions and be a threat to us? Hey, like we need more threats. Well, hey, let's have some fun with this. Some theorists reviewed humans' history and past actions toward one another. No miscongeniality awards there. And assuming they were somehow like us, used this to calculate the probability of space invaders. They determined that there could be 4 evil civilizations in our galaxy. The 4 could be eager for intergalactic domination, or maybe just for a good game of dominoes. They could be highly advanced in technology, or they've only just invented an evil version of game consoles. To understand how advanced these cultures could be and what to expect, there is a way to define their threat levels. A method called the Kardashev scale analyzes intergalactic nations' possible abilities. With 3 different levels, it reviews the amount of energy a civilization could take from their star, indicating their tech level. This only includes those that have reached interstellar communication. So any other beings out there using, let's say, space pigeons will of course be excluded. Type 1 shows that they can harness the energy from the sun, but only from what is received within their own planet, like solar power panels. Type 2 is where they can use the energy directly from the sun, like through a Dyson sphere. It's used to harness all of the sun's energy, having been built entirely around it. And lastly, Type 3, where civilization can use all elements provided by the galaxy, with the power to not only harness the energy from stars, but also black holes, even the central supermassive one. These levels are important to assess how advanced civilizations could be out there. The Milky Way is estimated to be around 13.6 billion years old. Modern humans have only been around for the last 200,000 years, and we're only a Type 1. It's scary to imagine the time other beings have had to develop. We're considered a bit of a late bloomer in comparison. Earth is, shall we say, late to the party because we're located on the outer arms of the galaxy. Mathematicians posit that more centralized star systems have had more time to progress. Now, with that in mind, how common would other intelligent beings be in the galaxy? With all the life-ending events Earth has survived, it's a miracle to have a planet like ours, and that we would be unique. Or are we? Well, there are 100 trillion stars in our galaxy, and there are up to 200 billion planets, with an estimated 300,000 exoplanets capable of sustaining the kind of life we know about. From those habitable planets, how could we tell which ones have other beings eager to send us an email? No one's had the time to individually count, of course. The Drake equation can give us some rough numbers if we take averages of a few key factors. It breaks down the criteria of how many planets with life are intelligent enough to make communication. The numbers are huge, considering how many stars might have planets. And from there, we distill it down further to those within the habitable zone in the solar system. This zone is called the Goldilocks zone, as it's not too far from the sun and not too close to it. It's just right. We reduce the numbers even further by calculating which of those habitable planets will then be able to support life. And from those random places, the equation takes the probability of how many intelligent beings will be and if they are intelligent enough to communicate. The criteria is complicated, and so it's not an easy equation to explain. But from its estimate, there could be up to 100 million planets with intelligent civilizations. But just like with Earth's history or struggles, these civilizations may also have their own challenges. World-ending events should be thrown into the equation, like asteroids, solar flares, supervolcanoes, and supernova. They could also destroy themselves through technology, like AI dominance or nanotech, or by affecting their own ecosystems and running out of resources, or by just acting stupidly. If we take these into the equation, the remaining living civilizations could be around 15,000. But what could they possibly want from humans? We do have an abundance of rare earth materials that could be of value, ready to be harvested and easily collected. Besides an appealing vast amount of water they could suck dry, hydrogen is a required element of rocket fuels. Though these things aren't exactly rare in the galaxy and could be harvested easier from other closer solar systems or asteroids. Our technology might be intriguing to them. Our range of innovations on Earth, invented while being isolated in separate countries, help provide different technology paths around the world. Other civilizations could have followed a completely different route and didn't learn the importance of many things we have here on Earth, like karaoke. The same goes for applied sciences, where they may have evolved in different atmospheres with different elements. Their science would be mainly affected by that, and ours would provide them with more knowledge. Then there's one of the rarest things in the galaxy, that Earth can support life. This would be very useful for an intergalactic traveler, rather than going through the long process of terraforming an unlivable planet. Why not just take it? With a cozy outpost, it would be a lovely little holiday destination when they need some time off from conquering other civilizations. Fortunately, they wouldn't be interested in eating us, or probably wouldn't have an appetite for anything on Earth. They would need to have similar biochemistry and require the same enzymes to process the molecules we're built from. Whew! But the most likely thing they would want is to remove any competition. The biggest threat to them is anything that would provide a challenge to their domination. But before you get too frightened by these evil civilizations, this was based on human behavior. It's possible that any beings out there could lack or avoid many of our human emotions. For instance, their capacity for anger might be limited, or they could have evolved without it. They could come from a world with a history so different from ours that they could be overly trusting, making us the bad guys. But again, they may also lack empathy and other positive traits we have. Well, let's hope they only have our nice traits. Luckily, there's a big thing that separates us from everything else. The galaxy is huge, and it takes a very long time to go anywhere, even to our closest solar systems. The fastest thing we've sent into space is the Galileo probe, which travels up to 100,000 miles per hour. Even so, it would take 72,000 years to reach the closest star system, Alpha Centauri. Still, with a newly proposed laser-guided probe that could travel at 1/5 the speed of light, it would yet take up to 20 years to make that journey. On a larger scale, the Milky Way is over 105,700 light-years across. If a civilization was even capable of light speed, it would take them hundreds of thousands of years to travel from one end to the other. With a huge distance between the small number of civilizations, the only successful contact would be through advanced interstellar travel. But to achieve such a long journey, the greater the mass to be accelerated, the more energy is required, so it's not likely anything too large will be sent. But they could travel here very quickly in a small shuttle, using the ability to break cosmic speed laws. They may already be here, watching us closely, or just binge-watching Netflix. They would need very advanced technology, and the number of species obtaining this is theorized to be only 2 out of the 15,000. That means there's a 1/100% chance of evil civilizations capable of visiting us soon. If they do know we're here, and they want something from us, it's likely to take them thousands, if not millions of years to arrive. So, we've got plenty of time to relax.
Did you know that humans are real space people? You were born in space. Heck, even I was born in space. We were all born in space. But for humans to be here on Earth, so many conditions have to be precisely correct that it's highly improbable that we even exist. But we do. First, we, and any other space creatures who might be out there, have to live on a planet orbiting a yellowish white star, not a red star or a blue star. Not a blue star, because they burn out too quickly. In a few million years, there wouldn't be time for evolution to do its relatively slow magic and produce intelligent beings. Blue stars also tend to swell up and turn red when they collapse and explode. It makes it highly unlikely that any civilization could prosper near a blue star. Red stars which are by far the most numerous kind of stars, don't seem like good prospects for intelligent civilizations to orbit around either. Red stars are so cold and so dim that a planet that could grow a civilization must orbit very closely to the red star, which would expose the planet to intense, deadly X-ray radiation. So, though red stars are the most numerous and appear to have many planets orbiting them, red stars are a no-go for hosting intelligent, civilized life like our own. That leaves the yellowish stars, about 10% of all stars. However, an important fact must be met before considering the possibility of intelligent life living around a yellowish star. That fact is that the yellow star must be a third-generation star. Only third-generation stars will contain sufficient chemical diversity to sustain advanced life forms. Each time a star explodes, heavier, more complicated elements are created. The explosion expelled these elements and eventually found their way into a nebula. Gravity within the nebula will gradually form the next generation of stars, and so on. Our bodies need calcium for our skeletons and teeth. Our brains need zinc to help create the electrochemical signals that make us move, feel, and think. Our blood needs iron. Therefore, our bodies need to have formed around a third-generation star, and a yellow one. Amazingly, Earth has all the different elements in the universe, all 94 naturally occurring ones, from hydrogen to plutonium. Maybe that's why we're here. And we have to thank our third-generation yellow dwarf sun for that. Why yellow? Because yellow stars burn very steadily by nuclear fusion without significantly changing brightness over billions of years. If our sun became just 6% brighter or dimmer, Earth would become too hot or too cold to sustain civilized life. Fortunately, Earth is in the habitable zone around the sun. The habitable zone is where liquid water can exist on a planet. But that brings us to the second condition necessary for intelligent life to live in space: the planet itself. Recent studies with the Kepler telescope have shown that 1/4 of all yellow dwarf stars may contain Earth-like planets in the habitable zone around yellow dwarf stars. That figure is somewhat debatable. It might be as few as 1 out of every 33 yellow dwarf stars, but that's still a lot of planets orbiting yellow stars in habitable zones. So let's consider the second essential component for intelligent life in space: the planet itself. The planet that would bear intelligent civilization must have many particular characteristics that aren't easy to come by individually, and even more rare to find in combination. Most importantly, the planet must have protection against the star it's orbiting. Because stars shine by nuclear fusion in their cores, gas in the outer shell of the sun, called the corona, gets blown off into space in what's called the solar wind. Our United States satellites take constant readings of the force of the solar wind, which is mainly electrified, ionized, hydrogen nuclei, along with a smattering of atomic nuclei from the many other elements found in the sun. It's not the atmosphere that protects Earth, it's the magnetosphere that stops or deflects the dangerous solar wind, causing aurorae when the solar wind is attracted to Earth's magnetic poles and electrifies the air of the upper atmosphere like a fluorescent bulb. Without a magnetosphere surrounding it, any planet, even those in habitable zones, would be toasted by a constant rain of ionized hydrogen nuclei from its star. A planet with life on it must have a magnetosphere strong enough to deflect the solar wind. Not every planet in our solar system has a magnetosphere. The gas giant planets, Jupiter, Saturn, Uranus, and Neptune, have magnetospheres, but gas planets cannot have civilizations. Of the solid worlds, only Earth and Mercury have magnetospheres, and Mercury is too weak to stop the solar wind because of its closeness to the sun. Another protective shield that keeps the Earth safe from the sun is its atmosphere. The atmosphere is about 300 miles thick, with most of it concentrated within just 10 miles of the Earth's surface. The atmosphere protects life on Earth from both the sun's ultraviolet, UV, radiation, and X-rays. The gas, ozone, which is 3 oxygen atoms bound into a large gas molecule in the upper atmosphere, blocks most of the sun's UV radiation from reaching the ground. The planet Mars, whose atmosphere is 1,000 times thinner than the Earth's, has no ozone, and the sun's ultraviolet emissions have totally irradiated its surface. A planet must be able to stop the UV radiation from its star, so the specific composition of the atmosphere is critical for any planet to have an intelligent civilization. We've got it. but it is a rare and precarious mix. The planet must have some part of its surface solid to walk and work on. The planet must have a crust. It's pure science fiction to consider underwater civilizations or floating civilizations in the atmospheres of other planets. A planet's crust must have tectonic plates that move. This movement of tectonic plates creates the subduction of the crust. Subduction is when one tectonic plate slides under or over another, bringing the fresh matter to the surface. This renewal of the chemical properties of the planet prevents chemical equilibrium, where nothing is reactive. Earthquakes and volcanoes also contribute to the process of geochemical renewal. That's right, earthquakes and volcanoes are good. Subduction of tectonic plates, then, is another planetary essential for life. Mars doesn't have tectonic plate activity. Neither does Venus nor Mercury. Mercury is one big tectonic plate, but there's no ongoing plate activity other than slight shrinkage. One big reason these planets have no life is that there's no geochemical reactivity because there's no tectonic subduction. And that brings us to the Moon. Yes, the Moon. To say that the Moon keeps us alive may seem like a stretch, but the contribution of the Moon to life on Earth is essential. First, the gravity of the Moon as it moves through space with the Earth not only makes the ocean tides ebb and flow, it also helps the rotation of the Earth to churn or stir the magma inside the Earth. The motion of the magma inside the Earth, with its high metallic content, contributes to the creation of the Earth's magnetosphere. So, the Moon keeps us safe in space by helping Earth become a geodynamo and creating our magnetism. The Moon is the largest moon in the solar system compared to the size of the planet it orbits. Essentially, it's primary. Many people consider the Earth-Moon system to be a double planet, but that's another issue. Another thing the Moon does that keeps life safe on Earth is to hold the Earth steady. Because the Moon is gravitationally locked to the Earth, the Moon acts much like a balance pole does for a tightrope walker. Therefore, the Earth doesn't wobble very much compared to other planets. This wobble is called libration. If the Earth wobbled as much as Mars or Saturn, not only would our weather become chaotic, but farming might have been impossible. These rare or unique astronomical circumstances work together to make Earth habitable for humanity. Many other factors are not astronomical, such as evolutionary, biological, and chemical factors required for life to exist on Earth. The probabilities, or improbabilities, are multiplying. Taken all together, we are very, very lucky to be here. In fact, we're so lucky that we may have hit the jackpot. Considering all the possibilities, it's doubtful that anywhere else in the universe is as fortunate as Earth.
At some point in its long and very interesting history, our dear planet Earth was sort of snoozing, just doing its planetary thing, spinning around the sun. And then, bam, life starts getting fancy. Plants and animals start strutting their stuff, showing off their complexity. Fast forward a bit, about 65 million years ago to be exact, and a cosmic disaster strikes, or at least that's what we presume. An asteroid probably smashed into Earth, wiping out the dinosaurs and other big animals. We can't pinpoint specifics about the asteroid, but we do know that it was extremely large and it crashed into our precious planet, creating a dusty mess that settled everywhere. You can still find remnants of that dust layer in sedimentary rocks today. If you dig beneath it, you'll uncover a whole bunch of fossils. These prehistoric creatures were living it up before the asteroid crashed the party. Think of it as the planet going on a cleaning spree, leaving a bunch of empty spaces waiting to be filled. And guess who took the opportunity? Mammals! These furry little critters were the ones to rise to fame. But why is it that this disaster became such a great opportunity for mammals? It's pretty simple, actually. With no big bullies around, they grew, multiplied, and had a population expanse. All kinds of mammals joined to fill in the blanks. Primates, rodents, basically, the whole furry gang. We're talking about placental mammals, marsupials, and even egg-laying mammals, adding some serious variety to the mix. We like to think of primates as our closest relatives here on Earth. What's their story? Well, around 63 million years ago, just a couple of million years after the dinosaurs' final dance, the primates decided it was time for a family reunion. They split into two groups, the dry-nosed primates, who became the cool monkeys and apes we know today, and the wet-nosed primates, who went off to become lemurs and aye-ayes, hey-hays. The fun didn't stop there. About 58 million years ago, the dry-nosed primates began their own little mission. One special guest called the tarsier, arrived on the scene, featuring big eyes that were perfect for late-night shenanigans. This tarsier took a different path from its primate relatives, embracing its unique niche and evolving separately. To this day, the tarsier is the only primate that feeds exclusively on meat. These little guys have a taste for insects, small birds, rodents, and even lizards. But that's not all that makes them unique. Their eyes are twice the size of their brains. Also, their heads can do a full 180-degree spin, just like an owl. Because of their features, the tarsiers are the true kings and queens of the night. With their superpower of ultrasonic tracking, they can spot their prey instantly. Plus, their legs and feet are like springs ready to launch them into action. They've got this special ankle bone called the tarsus, which gives them those epic leaping skills. Hence the name, if you were wondering. But let's leave these little critters to rest and get back to our story, shall we? About 55 million years ago, the Earth cranked up the heat, literally. This sudden hot pod was a bit too much for many deep ocean dwellers and plants to handle, and they bid their farewells. But hey, every goodbye is an opportunity for something new, right? The oceanic mammals known as cetaceans, saw their chance and took it. They splashed into those empty niches, becoming the rulers of the sea. In this category of creatures, you can find the blue whale and the dolphin. A special primate guest made an appearance around 47 million years ago. Scientists now affectionately call the fossil of such a creature Ida. This little wonder caused quite a stir, initially hailed as the missing link in human evolution. But here's the hilarious part. It turned out Ida was not one of us dry-nosed primates, but a cheeky wet-nosed one. Moving forward to 40 million years ago, this is when another big event happened in the primate world. The New World monkeys, our distant cousins, decided to take a different path and branch off from our lineage of Old World monkeys. They packed their bags and set off to conquer South America, where they're still living it up today. What's the difference between the two, you might ask? Well, one crucial thing that sets them apart is the fact that the Old World monkeys had nostrils that pointed downwards. Around 25 million years ago, another troop of apes entered the scene, and these guys had something special, the lack of a tail. These unique creatures would go on to become our closest relatives. We're talking apes and great apes, the cool gang who share a whole lot of genetic similarities with us. The first ape to break free from the monkey madness was the gibbon. About 18 million years ago is when this little acrobat swung into the picture. A few million years later, the great apes made their grand entrance too. Orangutans were the pioneers, venturing into the wilds of southern Asia. We're getting closer and closer to the present. It was 7 million years ago when the great apes took a major fork in the evolutionary road. One path led to our ancestors, the future Homo sapiens, and the other path led to chimpanzees and bonobos. These two primate branches remained united for a few million years before finally going their separate ways. 5.6 million years ago, a game-changing ape called Ardipithecus made its way into our evolutionary history. It had a special talent, bipedalism. That's right, this was one of the first apes to walk on 2 feet, probably making its primate buddies raise an eyebrow or two. The real showstoppers, however, arrived around 4 million years ago, the Australopithecus crew. These were the earliest members of the Hominina hominina subtribe, our tribe. What made them so special? Well, probably the fact that they brought some serious tools to the game. Stone tools, to be precise. It seems that at some point in their evolution, these clever primates started using stones to make their lives easier. Now here comes a crucial turning point in our story. About 2 million years ago, our ancestors faced a food shortage. Survival of the fittest was the name of the game, and two strategies emerged. Group 1 went for stronger jaws, allowing them to chomp on tough foods like nuts. Group 2 had a different idea. They opted for weaker jaws, but bigger brains. They wanted access to a wider range of food options. Obviously, the bigger-brained group took the prize. And here's where our gang comes into play. Around 2.5 million years ago, a type of primate also known as handyman made its mark on history. These clever beings had larger brains and knew how to put those neurons to good use. About 1.9 million years ago, a new star emerged, Homo erectus. These creatures not only walked upright, but also had brains that were almost twice the size of the handyman's. They took the world by surprise, becoming the first of our direct ancestors to venture out of the African continent. They even knew how to tame fire. Approximately 700,000 years ago, the world witnessed a culinary revolution. The earliest evidence of cooking appeared. And around 500,000 years ago, our ancestors decided it was time to become a bit more fashionable, donning the first evidence of clothing. Our very own species came to be just 300,000 years ago. Told you we were late to the party. But the world was never the same after the appearance of Homo sapiens, the anatomically modern humans. Alongside our other relatives, we emerged, ready to conquer the world with our innovative minds and complex societies. The exact path of our evolution remains a bit of a mystery. But what we do know for sure is that Neanderthals joined the party around at some point too. As Homo sapiens flourished, so did our capacity for language. Modern speech is believed to have emerged almost hand in hand with our species. We started expressing ourselves, sharing stories, and shaping the world with our words. So, there you have it. It took 13.8 billion years of cosmic history for humans to make their entrance. Think about it. 99.998% of the time since the Big Bang, we weren't even around. Our species, Homo sapiens, is the toddler of the Earth's family, existing for just the tiniest fraction of the universe's timeline. Yet, in this blink of an eye, we've managed to unravel the entire story that led to our existence. The story won't end with us. It's an ongoing saga, still being written with every passing moment.
The unanswered mysteries surrounding ancient civilizations have been a source of inspiration for many conspiracy theorists. In fact, some of these mysteries are so interesting that many of us either already believe them or would like to. One thing is for sure though, none of those thousands of conspiracy theories have ever been, what's the word? Oh yeah, classified. Or have they? We're all aware that the CIA has done some questionable things throughout history for the sake of national security, but you wouldn't expect a book to be both a national and international threat. The CIA recently declassified parts of a book that talks about lost ancient civilizations and the catastrophic events that made them vanish thousands of years ago. This mysterious book was written in 1963 by a guy named Chan Thomas, and it was going to be published by Emerson House in 1965 until the CIA got involved. For some mysterious reason, they classified the book, and it was never released to the public until recently. But here's where it gets interesting. The book was declassified in 2013 due to the Freedom of Information Act, but it wasn't released to the public until 2016. And what was released truly raises a few questions. The original version of this document was 284 pages long, but the PDF essay that was released was heavily censored, with just 57 pages, which makes it 1/5 of the whole document. The pages were edited before they were released to the public in such a way that you wouldn't even notice that the other pages were missing. Now, no one really knows why this book was classified in the first place, but it has some interesting content from what I've gathered. The author of the book had quite the imagination and a huge love for ancient civilizations. And even though what he had to say is very thought-provoking, some of it is just bizarre. He believes that our planet is locked into a never-ending cycle of pole shifts and Earth crust displacements that are responsible for the mass extinctions of many civilizations which existed more than 6,000 years ago, even before the Sumerians. He believed that these events caused more damage to the Earth than meteors, and he bases this theory on a few artifacts that exist around the world but weren't really noticed until recently. But I'll get into that in a bit. Those mass extinctions that the book talks about include the end of the Ice Age, when huge 2-mile-thick ice sheets disappeared from northern Europe, Northern America, and Canada, and caused 100 species to go extinct. And here's how the author illustrates his hypothesis. He believes that there was a geomagnetic pole shift which caused catastrophic changes to both the atmosphere and the Earth's crust, resulting in the extinction of many civilizations over time. Now, even though the geomagnetic pole shift is a real thing, it doesn't just happen overnight. It happens really slowly, only about every few 100,000 years, according to scientists. But it's a bit more complicated than it sounds. It is a well-known fact that the North Pole is somewhere above Alaska, and the South Pole is close to the middle of Antarctica. Now, these are the geographic poles, and they'll always be north and south. However, the Earth's magnetic poles flipped a few 100,000 years ago. So if you had a compass, let's say 700,000 years ago, it would instead point south and show you the Antarctic. But the author of the book has a different theory. He believed that the flip of the north and south magnetic poles doesn't happen every few 100,000 years, but every 12,000 years, and that this flip occurs in just a few hours, causing a catastrophic apocalypse. He thinks this happens as a result of an explosion inside the Earth's core. This explosion causes the magnetic poles to flip, but it also causes the Earth's crust to move. According to the book, due to these catastrophic events, a lot of the Earth's continents that were submerged underwater rose above sea level in just a few hours. Now, here's where it gets interesting. The author also states that the Peruvian Andes were beneath the ocean before the last pole shift. And even though it seems far-fetched, since the Andes are approximately 22,000 feet above sea level, there was evidence to support that claim in the late 80s. Scientists found whale bones and fossils that are said to be millions of years old on top of the Andes and the Himalayan mountains. It's also suggested in the book that the deep freeze the Earth went through during the Younger Dryas event caused the Gulf Stream to be disrupted. And he points to some interesting evidence to support that theory. Frozen mammoths were found trapped in blocks of ice with food still in their mouths. Now, this is a true mystery, because freezing cold weather is in their nature, and they were among the few animals that could truly survive in the Ice Age. So, what could have caused them to freeze so quickly? Kinda makes you go, doesn't it? The document describes the Great Pyramid of Giza as a true enigma as well. The Pyramid of Giza is made out of 2.5 million stone blocks that are placed on top of each other with great precision. It's close to 750 feet wide and more than 450 feet high. To this day, we're still not able to explain how it was constructed, and it's quite difficult to understand the internal design as well. On the inside, the pyramid has no similarities to the other pyramids, and, despite popular belief, there were no mummies found in any of them. If you think that's a bit weird, wait for the next one. There are absolutely no hieroglyphs found in any of the pyramids, and that goes both ways. What do I mean? There are also no pyramids, or anything that resembles a pyramid, in any hieroglyphs either. Mr. Thomas believes that the pyramids were created hundreds of thousands of years before the Egyptians by a civilization that went extinct. Speaking of civilizations, in his book he even mentions the Greeks. He claims that in Greece, there was another ancient race of people that went extinct as well. He claims they were extremely tall with blue eyes and blonde hair, and had access to advanced technology that the Greeks couldn't have known about in their prime. Now, before we drift too far away from the stone blocks, let's talk about another mystery, the temple in Baalbek, Lebanon, and its ginormous foundation blocks. Those stones, which make up the Heliopolis, were also used for the temple in Rome. The foundations of the temples are made of 900-ton trilithon stones, and according to the author, this is proof that there must have been a lost ancient civilization with advanced technology. Now, most archaeologists claim that those stones were made by the Romans. However, there's no evidence to support that. The Romans didn't have the technological equipment to make the stones or lift them. So, you might think, what if they just made them in that place right then and there? Well, those stones were also lifted 30 feet high and were placed next to each other with mathematical precision. And let's not forget about the blocks on top of the Heliopolis in Lebanon, which weigh about 800 tons each. But wait till you hear the next one. The Romans don't even credit themselves for these stones. They claim that they built up the sides, but they don't take credit for the extraordinarily large and heavy foundation stones. The author also makes an interesting point about the distance between the Roman capital and Baalbek in Lebanon. Why would the Romans build the world's largest monolithic stones in such a remote area, and so far away from their capital, and never take credit for it? Well, folks, it's a mystery to me. Now, let's move on to the most intriguing enigma, Easter Island, which is located in the middle of the Pacific Ocean, or nowhere, if you will. The author questions how people found it or even settled in such a remote island that long ago. One of the signifiers of Easter Island are the Moai statues and the mystery surrounding who they depict and why. What's an even bigger question is how they were created, moved, and positioned in the places they were found. According to this declassified document, Easter Island was part of the now lost continent named Mu, and it was sunk in the Pacific Ocean in a disastrous cataclysm that happened during one of those pole shifts. The continent of Mu, according to the book, was as big as South America, and what we now call Easter Island is just what's left of that continent. The author also believes that this is what happened with the lost city of Atlantis as well. Plato is even quoted about this, saying that the whole city of Atlantis sunk miles beneath the waves within just a day. Even though the whole story sounds very intriguing and makes some interesting points, we know that, scientifically speaking, a cataclysmic pole shift causing entire civilizations to go extinct isn't possible. Now, let's assume that another species, whether humanoid or dolphin-like, could have existed millions of years ago. How do we find their traces? There was a Doctor Who episode about a non-human industrial civilization on Earth that existed long before us. These reptiles, called Silurians, were forced deep underground by a catastrophic rise of temperatures on Earth, and there they thrived for centuries. That inspired scientists to create the so-called Silurian hypothesis. If there was an advanced civilization before us, we should find their traces somewhere. Well, let's try. Climatologist Gavin Schmidt and astrophysicist Adam Frank decided to dive into this themselves. Like us, any technologically advanced civilization would be hungry for energy, so they looked for global effects that would leave a widespread mark. For example, hints of large-scale industrial processes, like plants and factories, and their leftovers. Then comes the question of how long these civilizations would last. If they existed for a long time, we should look for long-lasting signs, like residues from burning fossil fuels, mass extinctions, synthetic chemicals not found in nature, and even traces of nuclear fission. Basically, we should search for the same kinds of things that humans are currently leaving behind as evidence of our activities. Unfortunately, this evidence isn't that easy to find. Let's imagine an unsettling scenario if humanity suddenly disappeared. Even though it seems like we've left a lot of changes on our planet, the future civilization millions of years from now would struggle to find any remnants of our existence. Why? Well, our planet has existed for 4.5 billion years. Complex life on Earth has existed for more than 400 million years. Compared to that, our industrial period only lasted around 300 years, and we haven't left any significant traces. Our record of Earth's history is full of gaps, especially the further back you look. The fossil record captures only some things, being very selective and incomplete. On average, one fossil emerges every 10,000 years, and dinosaur footprints are even rarer. Mountains rise, oceans change, and plate tectonics can easily wipe out evidence of entire civilizations. After a couple of million years, chances are any physical signs of a civilization would disappear. In order to find at least something, we have to look for things like odd sediment patterns or unusual isotopic ratios. Also, fossils mostly form in water, leaving us in the dark about creatures on land or in the jungles. So even if there was a technologically advanced society millions of years in the past, and even if they were far more advanced than us, we might struggle to find any clues of its existence. Frank and Schmidt try to understand how we could ever hope to spot signs of them. Discovering actual cities would be the ultimate proof of a Silurian-style civilization on Earth. But Adam Frank isn't too optimistic. Even now, our cities cover less than 3% of the surface, making it easy to miss ancient city ruins. Whether a city survives over tens of millions of years depends on whether the land around it is sinking, getting locked into a rock, or rising, getting worn away by rain and wind. So, places like the French Quarter in New Orleans might have a better shot of making it into the geologic record than, say, Haight-Ashbury in San Francisco. When it comes to finding artifacts, the odds are pretty slim as well. No prehistoric iPhone would survive millions of years, fancy glass or not. Finding their fossilized remnants might be a bit more promising, but it's still tricky. Considering modern humans have only been around for about 100,000 years, it's quite possible that we might overlook any traces of an earlier advanced species. There is one thing, though. We could stumble upon their traces in rocks. Our current chaotic era might leave a distinct mark on the Earth's geological history, especially since we're basically experiencing PTM 2.0. I'll get to that in a moment. So they try to look at the changes in the carbon cycle. Humans have been releasing a lot of fossil carbon since the 18th century. This leaves a special mark in the carbon isotope ratio, like a signature that shows the difference between carbon in living things, such as seashells, and carbon in lifeless volcanic rock. Scientists also look for signs in the way sediments are arranged. Large coastal deltas might mean that there were bigger rivers made by folks in this hypothetical civilization. Traces of nitrogen could suggest big-scale farming, where they used a lot of fertilizer. Spikes in metal levels in the sediment could mean runoff from heavy industries. Of course, a single find like that wouldn't tell us anything. Schmidt says the key is to look for multiple signs together. Without clear artifacts, the uniqueness of an event might show in various clues rather than a set of changes linked to a single cause. On a quest for Silurian-style clues, scientists even decided to check the Moon. Some astronomers find it surprising that no one has looked into this before. They even joked about the possibility of dinosaurs building rockets and leaving traces on the Moon or other celestial bodies. These astronomers think that Earth-like planets tend to erase signs of civilizations on their surfaces. So they're exploring the wild notion that these beings might have been space travelers. In that case, remnants of their technology, known as technosignatures, could be lurking not only on our Moon, but also on asteroids, or even buried on Mars. There they might endure for millions or even billions of years. Unfortunately, so far, despite digging into the past 380 million years and examining all suspicious events, the researchers haven't found a clear match for a technological civilization. They don't give up, though. Frank calls for more investigation. For example, we could study how modern industrial chemicals stick around in ocean sediments. This, he believes, could help us identify similar chemical traces in the Earth's history. If there are no traces, why do we even bother to find something like that? This research is based on Schmidt and Frank's recent papers. They were delving into the Anthropocene. It's the proposed epoch dominated by human activities on Earth. It's full of these things called hyperthermals. They're prehistoric events when temperatures on Earth sharply increased over a relatively short time. They're like extreme heat waves from the past. A great example of this is the Paleocene-Eocene thermal maximum, or PETM for short. It happened around 55.5 million years ago and saw a rapid rise in global temperatures. Over 200,000 years, the average temperature on Earth jumped from about 9 to 14 degrees Fahrenheit. We studied these hyperthermals to understand how they occurred, from natural causes or human activities. So, these hyperthermals sparked the genesis of Frank and Schmidt's research. To study them, scientists started examining chemical signals and tracers left in rocks. When doing that, Schmidt and Frank uncovered some eerie parallels between all the climate issues we have today and past periods of rapid temperature shifts. There's a close similarity between the PETM and other hyperthermal events. So all this work isn't just about solving a historical mystery. Understanding our impact on the environment can guide us to finding better ways to live in harmony with the planet and avoid becoming a forgotten species in the future. Our Milky Way is filled with lots of planets that could be just right for life, but we don't know if there are other civilizations out there. Earth is the only place we know of with living beings. About 200 years ago, people wondered if there might be civilizations on Mars. Back then, it was a real question. But once we got pictures from space probes, we decided there wasn't any evidence for it, and that idea got stuck in our minds. Now, it's not even considered a valid topic for serious science. It's seen as kind of silly. But no one has set clear limits on what could have happened on our own planet a really long time ago. So, even if there is no proof, we shouldn't throw away the possibility. Don't forget, it took humanity a while to recognize dinosaurs. Maybe Silurians are just patiently waiting for their time.